Professor Pfizer was a member of the German team that isolated and characterized the causative coronavirus during the SARS outbreak of 2003 as one of the first three worldwide teams that did that. He has served as a member of the World Health Organization SARS mission to China. His most notable contribution in the field of emerging viral infections since then has been the identification of a close relative to MERS coronavirus in a South African bat in 2013. His laboratory is a WHO pre-qualification evaluating lab for HIV, HPV, and HCV assays. His division's ongoing projects investigate HIV, latency and reservoir, HIV diversity and evolution, HPV and its role in hepatocellular carcinoma. So let me welcome all of you again and request Dr. Krishnaraj to please introduce Professor Samar Naike to the viewers and start the session.
Thank you, madam. Good morning, everybody. Professor Lakshman Samaranaike does not need any introduction in the field of dentistry otherwise. So you have given me a difficult and job to introduce him. But here's a small thing I have to say something about, sir. So Professor Lakshman Samaranaike, or also known as Sam fondly, is a renowned clinician, academician, and has extensive expertise in clinical microbiomics and a senior executive level administration. He is the author of over 450 scientific communications. Yes, you heard that right. And he's been cited over 27,800 times. His citation, that's his citations. He has served about 12 years as the executive dean of two major dental faculties at the universities of Hong Kong and Queensland, respectively. A highly sought after speaker, Professor Samaranaike has addressed scientific bodies in over 40 different countries and has received numerous accolades for its outstanding contributions to dentistry, including the coveted King James IV Professorship of the Royal College of Surgeons of Edinburgh, UK, and the Distinguished Scientist Award of IADR, USA. Even during the current COVID-19 pandemic, he has co-authored over 25 articles and has delivered numerous webinars on the subject. It is indeed an honor and privilege to welcome Professor Samaranaike.
Yes.
So, good morning, everybody, or good afternoon. Greetings from Hong Kong. I'm speaking from the University of Hong Kong. And I would like to thank Dr. Mandana Donahue for the kind invitation to be the presenter at one of the oral pathology seminars, which she has wonderfully it's a wonderful initiative, and so I really applaud her for doing that, particularly during the COVID season. And then I would like to thank Dr. Krishnaraj Ganesh Narayan for the very kind introduction. And I also I think we have, although we have not met, we have another sort of participant, Dr. Wolfgang Preiser from South Africa. So I haven't met him, but also welcome to him. And then welcome everybody to this particular seminar. So without further ado, I will be talking for about 40 to 45 minutes. Let me share my screen. Right, so I believe all of you can see the screen. My presentation today is on COVID-19 vaccines and the dental team. Now, what I have to tell you, the very onset of the presentation is this: the whole field of COVID, as you all know very well, is changing so rapidly. And so whatever I say today can be different tomorrow. So I have delivered this particular lecture on several occasions, and each time I keep on updating the presentation. So without further ado, this is my outline of my presentation. So I will be giving some historical aspects of vaccines in general. Then very briefly, I will talk about vaccine theory. how vaccines work, then COVID-19 vaccines and the immunity, and some take-home messages with regard to dentistry and oral dentistry and the vaccines and what the future is going to be, and in our profession, what are our obligations and ethics in relation to vaccine, and some concluding remarks. Now, I'm not going to talk to you about the numbers, not too many, just one or two slides, because I'm sure all of you know about this. So today, as of today, we have 219 million cases worldwide, and unfortunately, 4.5 million have died or succumbed to this nasty pandemic. It's but in comparison to the previous, like the 1918 influenza pandemic, which killed apparently over 100 million people, it's not that heavy. But even one death is bad. But we have now 4.5 million vaccines, rather the total deaths. Now it is as I always say, it's the ingenuity of the humans as well as the technological advances. We have had the vaccine for COVID-19 within 9 to 10 months of the discovery of the virus, SARS coronavirus 2, which causes the disease. And what is very clear is, and this is a slide which I got today from, actually I got from the Economist. You can see these are the number of COVID-19 patients in hospitals per million on yesterday rather. So you can see in lots of these countries where the vaccinations have been very, very low, the numbers are very high. The highest, there's no awards for this. US is, although they say about 60% vaccinated, apparently there are 283 million, 283 per million of the population. And you can see, in some countries like Poland, Norway, only like 16, 13 per million individuals. So, I mean, these are mostly countries where the vaccination is very well done. So the vaccine is very, very effective and efficacious. And then very, very briefly, I will touch you about the natural history of the SARS coronavirus. And you can see the COVID-19. You can see from the y-axis, the viral load is on the y-axis, and on the x-axis is the time since symptom onset. And you can see clearly that, it's the symptoms, there are the pre-symptomatic phase where there is cough and sneezing and so on and so forth. Then the viral numbers grow up after like the 4th day of the disease is the, they have been doing actually just now they are doing natural so-called challenge experiments, inoculating healthy people to trace the natural history of COVID. And this is done as we speak in UK. And they have found that from the 4th day onwards, that the virus starts the multiplying and starts spreading. So these studies are going on as we speak. So, but this is the current situation. So you have the disease divided into 3 different phases: the mild, moderate, and moderate, severe illness, and critical illness. And you can see as the severity of the disease increases, you need to have hospitalization and ICU admissions and so on and so forth. And side by side with this, which is the more important for us in terms of the antibody response, is initially we have the after infection within 7 days, the first antibody to respond is IgM. Then you get the IgG antibodies coming up, and these are the ones which actually essentially protects these are the IgG antibodies which we try to create when you inject the vaccines. And then this is the immune response. So if you have one vaccine, just to give an example, your IgG immunity level, antibody levels will go up. And you have a booster, this curve will show another peak, and that will hopefully, together with the initial one, will prevent future infections. Now, let me just, I got 2 slides on the beginning of the vaccines. And now it's been said that Edward Jenner is the father of the vaccines, right? And I mean, he actually, this is the time during the smallpox, he realized that the cowmaids who are milking cows did not get smallpox, but they get some kind of a disease which is similar to smallpox but not deadly. It's called the cowpox. So what he did was, he thought perhaps, you know, if somebody gets infected with cowpox, then it may be that you may not get smallpox. So what he did was, he on this day, he took fluid from a cowpox blister and stretched it into the skin of this child, James Phipps, an 8-year-old boy. So it says here, single blister rose up on the spot, but James soon recovered, and Jenner inoculated the baby again. And this time the baby, this child did not get smallpox. So that is the documented history in most of the textbooks. But I'm going to tell you something which is slightly different, which I discovered when I was writing another article to the Journal of American Dental Association. The origin of the vaccines, so-called vaccines, actually begins in China. You may be surprised to hear that. This particular picture, which is available in the Philadelphia University Museum, it says that approximately 1000 AD, the son of a Chinese statesman inoculated himself against smallpox by blowing powdered smallpox sores into the nostrils. You can see the child being, or the person getting the powdered smallpox the material. So actually it goes, you know, 1000 AD, and if you look at this one, this is like 1796, 1800, but apparently it's much older than that. But anyway, so that is a little bit of history for you. And what is interesting is that this vaccination, which is has been done, you know, thousands of years ago through the nose, and we have the mucosal vaccines for COVID. We are going to have hopefully in the future, and they are in the trial stages. And these vaccines are now, so it's going back to this historical aspect of it. So it's quite interesting that we are still trying to emulate that kind of, you know, that kind of option for vaccination. But more of that in a moment. So if you look at the vaccine statistics, I mean, there's a vaccine database there are so many in the internet. And today, up to today, you can see the world vaccine, the doses, half a billion vaccines have been given. 2.3 to 2.4 have been vaccinated, fully vaccinated, getting both doses. And the percentages of the globe, which is fully vaccinated, is 30.3%. And I'm sure all of you have heard of that. This now, they say that so as to get so-called herd immunity for the world or for a country, 70% of the population has to be vaccinated. But now they say with the Delta variant, I think they have kicked up the number to 80%. But we can see we are not even halfway there. But hopefully, in a few months' time, we will reach a critical point where the spread of the disease will be at least, you know, not totally abated, but at least partially abated. So you can see that again, you know, this is the vaccine politics and, you know, geopolitics. The numbers vaccinated, but they are totally disparate in terms of the different countries where the vaccinations have been happening. You can see the US. Well, I'm not saying that they are holding the vaccine, but they have plenty of them. but in other countries, very poor regions of the world, the vaccines are insufficient. I'm not going to go into these details, but there you are. So if you were to understand the vaccination process, you have to understand, I'm sure you would have heard of the term vaccine trials. So the vaccine trials are the so-called phase 1, phase 2, and phase 3. Before the phase 1, they are the vaccine is tried out in the laboratory, in vitro analysis to see the antibody response. But then phase 1 is a small group of people, up to 10, 15 people are given the vaccine. And here there's no control group. And if this is terms, the vaccine is thought to be efficacious, then you go to the phase 2, where you have a control group and a test group in the population. So this has to be done in an ecosystem where the disease is prevalent. Otherwise, you can't carry on these tests. So that is one of the reasons that SARS virus 2003 vaccines, although they developed, they can't trial them because there is no SARS. Thankfully, the SARS virus actually totally disappeared for some reason. Nobody knows the reasons why. And that is one of the reasons why Trump was saying that just want to go back, that this even the SARS-CoV-2 will just go away in a few months' time. So anyway, going back to phase 2, so you have a small test group and a small control group is coming up to 30 or 40 people. And if this is successful, the vaccine is successful, then you go to big trials where thousands of people are involved in phase 3. So once the phase 3 trials are conducted, and then if they are proven to be efficacious, then you are applied for FDA approval. Now, what happens just now is that the FDA has approved, given the preliminary approval for all the vaccines which we are having today. The total final approval has not been given only to the Pfizer vaccine so far, but I believe the Moderna vaccine is going to be getting the final approval very soon. So because of the dire situation of the FDA approval is given kind of presumptively looking at the phase 3 trials. So these are the phase 1, phase 2, phase 3 trials we are talking about. So as I said, due to the human ingenuity and the technological advances, since from 9 months since the SARS was discovered, we had a efficacy data released within 10 months and a vaccine which is effective during this period. So this is a thank goodness for this. Otherwise, there'll be much more people dying in this case. So there you are. So this is the beauty of the technology, and the people who are working. We should be very thankful. So you can see the vaccine trials. There are so many people who have joined the bandwagon. Now these are the numbers from the database, which I copied on the 1st of September. Phase 1, 54 vaccines tested. Phase 2, phase 3, authorized 11, approved 8, and abandoned 5. So thankfully, we have got a plethora of vaccines which are available today. And we should be really grateful for those who are doing the work on it, and so that the vaccines are relatively cheap in comparison. So the vaccine approval process, very quickly, you have the early or limited approval, as I said here. Then the complete, before the trial results, regulators review the complete trial results, give the approval, and then you have, in order to accelerate vaccine development, you can combine all these phases and so on and so forth. Okay. So let's get down to the more focused aspects of this. The vaccine, essentially, it's a very old process. I mean, COVID is not the first vaccine. We have so many different vaccines, bacterial vaccines, viral vaccines, which I'm not going to talk about. So the active ingredient is the particular antigen, either the viral or a bacterial antigen, which actually stimulates your immune system, okay? So you can't just put the antigen into a glass vial, but so we'll have to have sometimes other additives. Then also sometimes we have something called adjuvants to boost the immune response of the vaccine as well. And I'm not going, I mean, this could be aluminum and so on, but some COVID vaccines may have adjuvants as far as I know. Then you can put antibiotics and to prevent bacterial growth within, because sometimes vaccines are kept in tropical countries for months on end, depending on the end date of use. But so therefore you need to have antibiotics, then you have the stabilizers, and sometimes you have to put other preservatives called thimerosal and so on and so forth. So sometimes you can get, and actually the hypersensitivity to some of the preservatives, and that's why you get allergies to vaccines. And then of course you get trace compounds. So essentially this is what you get in your vaccines. So after that, let's now talk about how vaccines work. Now, essentially, again, I'm sure all of you know all these details here. If you were to vaccinate somebody, then you will have to expose the human immune system to the organism, right? So what is the first part of the organism which comes in contact with the human immune system is either the cell wall of the bacterium or the outside projections of the virus. So these are the so-called spike glycoproteins which are on the outside surface. So I always say this example: if you want to catch the virus, if you want to catch a thief, you want to know what it's wearing. So what the SARS-CoV-2 is wearing is the spike glycoprotein, and if the immune system is primed by the spike glycoprotein, and the immune system knows as soon as the true infection happens that okay, the thief has come in to kill you, and then they can produce T cells and antibodies. So this is the spike glycoprotein, which is all important in this context. And if you blow it up, you can see the viral spike protein. It's just like a petal, a flower with 3 petals. It has subunits S1 and S2, and so on and so forth. And actually, these just incidentally, when these subunits start changing, that's when you get these vaccine variants, the variants of the virus rather. So we'll have to have a different vaccine for the variant, or a modification of the original vaccine for that particular variant. So it is in this region that mutations happen. You get so-called antigenic shifts and antigenic drifts in these viruses. Okay, so once, just very quickly, the process of how the vaccine enters the body. So you get the spike protein, and in most of the cells of the body, we have a receptor for this spike protein, which is called the ACE2 receptor. Mind you, I'm giving you a very, very simplified version of this, which is much more complicated than this, but these are the essentials of it. So the spike protein actually latches onto the ACE2 receptors, which are expressed on a lot of cells of the body, as you will see in a moment. And thereby, as you can see here, the SARS-CoV-2 binds ACE2 receptor, and the virus is taken into the cells, and the viral genome is released, and the RNA is copied and duplicated, and you get the process which is here. And so it's beyond the remit of this talk for me to present the details here. So here you are. So that's what it is, the process, right? So now I said that the host tissues express the ACE2 receptors. Now you can see from this slide here, oral cavity is a prime oropharynx is a prime area where you get this expression of ACE2 receptors. Salivary gland cells, the oral cavity, the mucosa cells, all expresses so-called ACE2, and other one is called the TM press, which actually helps the viral entry. You can see that in all these places, lungs, heart, the endothelial cells, you get this expression of ACE2, and that's why you end up with all these cases like endothelial dysfunction, myocardial failure when you get the vaccine, when you get the real disease. And sometimes you can get myocarditis. You have heard about people getting myocarditis after the vaccine a few days or a couple of weeks. That's because the heart also has the ACE2 receptors, and therefore it reacts with the antigens in the vaccine, and then you can very simply you can get the vaccination. You can get the myocarditis. Okay. So this is the famous pictures from the University of Hong Kong. You can see the virus budding from the surface, and I'm not going to go into details there. Okay, so how do vaccines work? So essentially, so there are 4 or 5 or 6 different vaccine platforms, right? So essentially what we want to do is to expose the body's immune system into the spike protein, right? So for example, if you take the lipid mRNA vaccine, which is a new platform vaccine, so the messenger RNA, which produces the spike protein, is enclosed in a lipid globule and is injected. So once it's injected into the body, mRNA proteins are translated, and then you get the production of the spike proteins inside the human eukaryotic cell, right? And then they are taken up by the antigen presenting cells and presented to the T and B T cells, and through them into the B cell via T helper cells. So first, cytotoxic T cells are produced, which can recognize any new infection which contains the specific viral antigen, and it can kill the cells. So it can have killer T cells, can kill those cells. So this is a T cell response. The other one is the T with the help of the T helper cell. This is the more important one, where you get B cells are primed to release the neutralizing antibodies because of through this antigen processing. And these antibodies actually bind to the virus before it binds to the human cells. So it has to catch the virus as soon as it enters the human body, and then it really aborts the infection at that point. Then, so how do we have vaccine memory? Let's say you are vaccinated, like we were vaccinated for measles, mumps, rubella, and TB long time ago, right? But if we come across these infections, then our body is still protected. These are by the memory T cells. The memory T cells is like actually a bank of cells where you can get, as soon as it's exposed to an antigen, in this case, the SARS-CoV-2 S protein, there is so-called polyclonal activation of T cells, and same type of clones are produced, and they produce antibodies and T cells and so on and so forth. So this is the very basis of the vaccines, and this is a very immunological process. It's very, very basic, and it has been simplified, but there are so many other numbers of intervening steps which I'm not going to go through at this juncture. So if you take the different vaccine platforms, we have here number 1 here, the mRNA vaccine. Then you have the attenuated, live, and the whole inactivated vaccines, right? I'll go through these later. Then you have subunit vaccines, then viral vector vaccines, and the DNA vaccines. So all these are actually work on the same principle, which you see in the center here. So the antigen is injected, the antigen presenting cells are taken these, and then produced either the T cells or B cells or the memory cells. Okay, so these are these are the different platforms where the vaccines are produced, and One of the more modern platforms are the RNA vaccine platforms, which is the Moderna and the Pfizer vaccines. But some of the others are very, very old. For example, the adenoviral vector vaccines, we have, and the subunit vaccines, we have already, for example, the subunit vaccines for hepatitis B and the viral vector vaccines are available. The DNA vaccines are relatively new and they are being produced. So here we go, the major vaccine platforms, the mRNA, the new platforms are the viral vector vaccines, is a new platform. Viral vector vaccines is an old platform. DNA is a new one, and the others are old ones. So these are the 5 different types which we have now essentially. No, DNA vaccine we don't have, essentially 4. So as I said at the very beginning, we have mucosal vaccines which are in phase 2 trials. Can you remember the phase 1, 2, and 3? And then also I would like to tell you, I'm sure some of you may have heard about another type of vaccine in a moment. So, so these are vaccine platforms, the mode of action. So example of SARS-CoV-2 vaccine and currently available for So mRNA vaccines are Moderna and Pfizer. So delivers one or more SARS-CoV-2 RNA genes into cells. So Moderna and Pfizer is the vaccine. DNA vaccines are coming through. Here we have a so-called a plasmid incorporated in the in cells with the help of a plasmid. I'm not going to go into details here, but this company called Innovia and Inno4800 is the one which is being produced, and it's been already used in veterinary infections. So they are saying that the SARS-CoV-2 vaccines are coming along. Then the viral replicating vaccines. So what we do is a virus engineered to carry the coronavirus gene. It's like a Trojan horse principle, but not replicating, enter the receptive cells and instruct the cells to make a viral protein and replicate carrying coronavirus protein to the surface. So, and this is an example is the AstraZeneca vaccines, which is currently used all over the world. And another viral vaccine currently in use is Ebola infection. Then subunit vaccines, these are small proteins which are used, fragmented antigens, and they are used currently, the GSK vaccines, Sanofi are the ones which are now in production. Already we have hepatitis B subunit vaccines. The next group is these are different platforms, as you can see, the inactivated or attenuated viruses. So as the name implies, they are inactivated or attenuated with chemicals, and Sinovac, Sinopharm, the Chinese guys are doing this, and again there's an Indian one called Bharat Biotech, and we have a whole host of inactivated vaccines we have already taken during childhood. Now this is the surprising thing, anti-vaxxers, most of these guys I believe have taken the childhood vaccines, but these are still they are against taking these vaccines. Then the mucosal vaccines I mentioned earlier, sprayed into the nasal mucosa. It's a spray. Phase 2 trials are now on for the SARS-CoV-2 or COVID. The influenza vaccines are thought to be in production now. And very interestingly, they are now actually trying to produce a vaccine is a COVID in a pill without, so this will be very, very easy for us to take once in 6 months or once in 12 months or whatever. So this is actually phase 1 trials are done by phase 2 or 1 to 2 trials are now being carried out by Pfizer. And this is really, really good news for all of us. So why do people react differently to the same vaccine, right? So I want to give you some important concepts. Some of you may wonder why, one person produces a lot of antibody and the other person does not. So antibodies produced by the body after the vaccination can be classified into neutralizing antibodies, non-neutralizing antibodies, and so-called broadly neutralizing antibodies. So the holy grail of the vaccine producers is to produce neutralizing antibodies. So these are the ones which neutralize the virus and which attaches to the spike protein, right? But non-neutralizing antibodies may actually have some effect because they will attach to some parts of the viral structure, but they are not as effective as neutralizing antibodies. Now, the third group, which is called the broadly neutralizing antibodies, is something which can be, which they say can be produced for viruses like HIV, where the antigenic shifts and antigenic drifts happen all the time. You know, fortunately for these coronaviruses, the antigenic drifts are relatively slow, and we have only very few variants. But like HIV, you know, that's why they can't produce a vaccine for HIV, because of the very, very quick changes in antigens. So for these, they say the broadly neutralizing antibodies are important, but that is by the by. But what we want to, in the case of coronaviruses, is to have neutralizing antibodies. And there's another important concept. So this is why some people have different kind of reaction to the antibodies and resistant to infection. So immunity after vaccination can be broadly divided into effective immunity and sterilizing immunity. So what are these two terms? Now, sterilizing immunity is when you produce antibodies so that in such large quantities and such efficacious, in a such efficacious way that the virus cannot live on your cells, even as a, you know, as a kind of a common cells. But if you have sterilizing immunity, so you will not have virus on your cells or in your throat or in your lungs at all. But in the case of effective immunity, you produce antibodies, but the antibody level is not very, very high, but it will protect you. It's effective, right? But the problem is that you will be carrying some, you know, viruses in your throat or in your lungs. So when you cough or when you speak or when you sneeze, these viruses enter the circulation and cause infection in others. So that is why they say that now, because the COVID is very, very infectious. In fact, the Delta variant is so infectious that even if you are vaccinated, that you have to keep wearing the wearing mask when you go out and when you go in small, when you are in small contained spaces. So please remember this, you know, that, you know, there are two types of immunity, and that's why, you know, every person is different in terms of the immunity they produce. So you are very lucky if you get sterilizing immunity, and you can be evaluated for these things. So that is very, very important. Please remember this. That's why I have put these 4 stars. So there are some more things on vaccines which I just want to, you know, give a broader idea of vaccine. So here we are going to talk about the vaccine efficacy and efficaciousness, strain selection, pre and post-vaccination serology, heterologous vaccination, mixed mode vaccination, non-responders, and boosters. Now, why am I going to tell all this for a dental audience? Because as you will see later, that we as dentists is sometimes the go-to person by a lot of your patients, your staff, your dental team, your family, because we are clinicians, and sometimes we also have to give vaccines. Like for example, in US, you know, dentists were asked to vaccinate people because of the dire situation they were in at that time. So, but beyond that, dentists are very, very important here in this context. And so we have to know a little bit of the deeper understanding of the vaccine, how vaccines work. So let me take one more these one by one. So what is vaccine efficacy and vaccine effectiveness? You know, a lot of people think that efficacy and effectiveness are the same. So much so that when I wrote an article on it, even I had to argue against one of the reviewers that he didn't know the difference, unfortunately. So here the difference is this, you see. So the vaccine efficacy varies from one vaccine to another. So like in the COVID, it can go from 55 different platforms. In mRNA, it goes up to 95 in sometimes, for example, the Sinopharm, Sinovac, 55 to 60%. So it's a broad range. So the vaccine, so what we mean by vaccine efficacy is the percentage reduction of disease in a vaccinated group of individuals compared with the unvaccinated group under similar conditions in a vaccine trial ecosystem, right? So, so what do you mean by a vaccine trial ecosystem is now in the phase 3 vaccines, like for example, phase 3 vaccine trials, Sinovac or Sinopharm was trialed in UAE, United Arab Emirates, whereas Pfizer and I think Moderna was trialed in, if I'm not mistaken, in some South Africa. So within that ecosystem, if there are lots of infections, right? So the vaccine efficacy varies in comparison to another ecosystem where the vaccine is trialed, where the infection is less prevalent. I don't know whether I explained this properly. So that's why you get initial huge variations between vaccine efficacy between Sinopharm and let's say the Moderna or Pfizer. So that's why they say they are not directly comparable, but there is broad comparability, of course, but not directly comparable. Okay. So what is vaccine effectiveness? Now, this actually was given earlier called the field efficacy, right? Now, this is the ability of vaccine to reduce the diseases in a vaccinated population over a substantive period. So, given the constraints associated with the vaccine. So, for example, so these vaccines are very new, right? So, I mean, they are now about what, 6-7 months old. Substantive period meaning up to about 1 to 2 years, perhaps, or longer. So the effectiveness in a population cannot be equated with the efficacy in a trial situation. So that's why these two are different. So remember these nuances in the efficacy and effectiveness. Okay, now I just want to give you a comparison of these are the ones. The top one is a seasonal flu vaccine efficacy. And compared to all these are all COVID vaccines. You know, Pfizer, Novavax, Sinovac, right? All these. So you know, Pfizer is 95%, and so on and so forth. Sputnik 90%, and so on. Now compare this with the seasonal flu vaccine, which we dentists have to take every year. I don't know whether some of you take, but in UK and US, we are supposed to take them to protect us from the seasonal flu. So the efficacy of that is 50%, roughly 50 to 60%. So these are rough numbers, of course. So you can see almost all of these vaccines which we now have for COVID is better than the seasonal flu vaccine. So I think we can't grumble. So that's why I tell people, any vaccine is good and a good vaccine. So please take them. You can't be waiting for the good vaccine to come along, and then you will get the disease and possibly get hospitalized and possibly, have severe consequences. So please remember the efficacy and effectiveness. So there are so many other factors, and we are still talking about the reasons why there are vaccine efficacy, seroconversion is variable. You can see in this slide here, the blue circles relate to the vaccine, and the green circles relate to the human individual. You see? So if you take the individual, There are things called the body BMI, the comorbidities, gender, age, pre-existing immunity, and whether it's effective or sterilizing immunity. There are things called immune imprinting, immune senescence, but I'm not going to go into details. The point of this slide is to show you why different people have different vaccine responses. And these are, of course, for the related to the vaccine, the dosage, single, dual, or 3. Now people are talking about 3 doses, 4 doses, vaccine strain, the timing of the doses, and the booster doses, and so on. Okay, so these are the reasons why you have different responses to the different vaccines, and there are multiple reasons for it. And you cannot expect the vaccine to say, let's say, Moderna is 95% efficacious. Everybody will not be have 95% efficacy for that. So I think I have covered this. Which vaccine, if given a choice? Okay, here we have the debate about the vaccine could be given of the same platform should be used, like Moderna and Pfizer could be okay because they are mRNA vaccines, or you can mix and match Moderna and AstraZeneca. So these are called heterologous platforms, and they are from different platforms. No, funnily enough, people at the very beginning, they said that, this should not be done. But now people, a lot of scientists have proven that actually combination of vaccines sometimes, depending on which combination, gives even a better response. I have got some, okay, here I think we got this one here. So heterologous dosing with adenovirus AstraZeneca vaccine followed by mRNA induce stronger immune response than the homologous vaccines. So both humoral and cellular responses, that means B cell and T cell responses were synergized by the heterologous vaccination. And you can see this, like you can do the same one or different ones, and you get different responses. And against also again towards SARS-CoV variants, and this is shown in this scattergram taken from the Nature particular article. You can have the 2 vector vaccines and a vector and an mRNA vaccine, an mRNA and mRNA vaccine. You can see the response, antibody response, CD8 T cell response. You can see this is much higher. So heterologous vaccination, I don't know whether it will become routine, but it is supposed to be better. So it's an interesting fact about this. Okay, now pre-vaccination serology. Let's say if you have had the COVID infection before, do you have to take the check your antibody levels before you give a vaccine, or whether you have to take the vaccine at all? So there is a little bit of a debate here. Some say if you have had the real natural COVID infection, your antibody levels are pretty high, but nevertheless, you have to take the vaccine. So I think it's you have to watch this space a little bit later, for more information coming up. Post-vaccination serology. Now, if you all remember, I think most of you listening are dentists. And if you remember, if you take the hepatitis B vaccine, for example, you get a 95% seroconversion, and like 5% of the people do not seroconvert. Therefore, you have to, after the 3rd dose of the hepatitis B vaccine, you have to check your antibody levels 6 months later after the 3rd dose. So as to get your so-called immunological correlates. So you have reached the appropriate antibody level. So in the case of hepatitis B, it's 10 mega international units per milliliter. Now, does that situation arise in the case of COVID vaccination? We really don't know. We don't know what the immunological correlates are, but people are working on these, and in time to come, you will have to watch this space. You might have to do it, or a lot of people do it. That's why they find that your antibody levels have gone down drastically after 3 or 4 months. Now they are saying that you will take the third dose and sometimes even the fourth dose. Israel is going to be fourth dose as well. So these are very controversial areas, but it's likely. But a lot of people forget about the boost, the memory cell response, which actually, even though you don't have antibodies, they can actually protect you. So what I also, whether there are non-responders to each of the vaccine, in that case, you have to give a third dose, or you try a heterologous platform. You can compare it with the hepatitis B vaccine. You can give a fourth dose, and so on and so forth. So in our industry, in dentistry, so we have to ensure that all the people you are working with are properly covered and have proper serological antibody levels for these for the COVID-19. So booster vaccination, yeah, of course. I mean, this is a little bit of old slide, 3 months old, but of course, apparently it's not now necessary. How frequently? Now we know that the flu influenza vaccines we have to take every year because of the antigenic shifts with the influenza common flu virus, and it appears that the variants are causing this, and we might have to take these booster vaccination. Okay, as I said, the pill vaccine will be a game changer, and in fact, that a lot of people will start taking it if we get it. So let me in the next 5 minutes or so, let me talk about the variants and vaccines. Now, so the variants, I mean, they happen because of the spike protein, as I mentioned earlier. The three petal area, the top area, the latching on area, you get the antigenic variations. So there are so many different things that can happen, and the WHO has divided variants. Earlier, it was like the alpha variant was from UK, I believe. The delta came from India. So now they call alpha, beta, gamma, delta. And they divide into two types: variants of concern and variants of interest. And you can see that they are watching these guys very carefully. I mean, delta plus, epsilon, iota, and lambda, and so on and so forth. So you can see you have to watch this space. And you can see where these are going in this particular slide. Delta is now taken over 95% in UK, 90% in the US, and various other places. So it's a very, very highly infectious virus, almost 100 times more than the alpha variant. So that's why it's spreading much more rapidly, and the need for wearing masks and so on. So this shows I'm not going to go into details, the variations on the alpha, beta, gamma, and delta in the spike protein, and you can look these up. So, so very interestingly, this is again a new slide. The COVID-19 vaccine should be actually efficacy against the Delta variant. So you can see this, any COVID-19 infections. Okay, I am not going to go into details, but important thing to note here is for severe COVID-19, Pfizer and Moderna has been excluded.
Professor Samanaike, we lost your voice.
Can you hear me now?
Yes, please.
Okay. So, okay. So now, sorry about that. So we will go back a little, and then we have the so we can see the severe COVID-19. You have got the Pfizer, Moderna. All these are very, very effective. And then we go on to the also the symptoms with these variants actually change when you are partially vaccinated and fully vaccinated. And the thing to remember is, in these vaccinated people, you do not get the original strain. We had anosmia, can't smell things, and the shortness of breath apparently is not there, but they have these go back here, you can see it's there are different types of symptoms if they actually catch the variants here, right? So partially vaccinated and fully vaccinated. So yeah. So effectiveness of the variants or vaccine potency differ between platforms. Delta is the most worrisome, twice as transmissible as the corona that caused the pandemic, globally dominant, and you can see more resistant to vaccines. And now say the 80% of the community have to be immunized for herd immunity because of the very high spread of the Delta variant. And for the Delta variant, Pfizer and BioNTech, as you saw earlier, appears to be more effective than that. So I'm just skipping that slide. So some take-home messages on COVID-19 vaccines. My last about 7-8 slides. Extremely good. How good are the COVID vaccines? But there are breakthrough infections. But the important thing is if you are vaccinated, they will protect. So that is only less than 1% of the people vaccinated are now hospitalized, and that is very important to realize. So they have found that 10% increase in vaccine coverage is associated with a 7% reduction in the case fatality. And also, can you remember the sterilizing immunity and effective immunity? Sterilizing immunity produced in a majority of cases. And then the vaccination associated with 50 to 40% reduction cases in household contacts. Yeah, so the quality, as I said, varies, efficacy varies considerably because of the various reasons. Are vaccines, some vaccines better than others? Yeah, they say Moderna and Pfizer is the best. As I said, any vaccine is better than no vaccine. And again, I explained this to you, why it's difficult to compare vaccines, because they have been trialed in different parts of the world where the prevalence of the disease is different, and therefore they are not directly comparable. So, so therefore you have to, yeah. So how durable the protection? Then there are some of the initial data. Efficacy peaks at 96% in 2 months after the second shot and declines gradually to, and so on and so forth. And then by an average of 6% in every 2 months. So there's, of course, this is natural because we have the IgG antibodies, and these are proteins. Proteins are broken down all the time unless they are exposed to a new antigenic exposure coming in from outside. But this is normal. But the sudden varying, if it is a very, very sharp decline in the curve, then one has to be very careful, because you don't want to go into a situation where there are 0% antibodies. But hopefully, some of these vaccines with some adjuvants and changes can be developed into others. Hello? Sorry about that. So then we move on to the next one. So I think we have come into the final stages of the presentation. What are your obligations as a dental professional? Because a lot of us listening here are dentists, and it's very, very important that we actually are aware of, as I said, about all the nuances of the vaccines, because, as I said earlier, we are the go-to person as a clinician. People will ask you about it. So I'm just giving you a list of things why we should be obliged to study these and be in touch with this literature all the time, because it's a moving field, it's a moving target. Things are happening on a daily basis, and you have to ensure that you know what you're talking about. So why should we know about them? We have to take them routinely annually, and then I don't know about this actually. So like the flu viruses, vaccines, we might have to take them annually. So we don't know about it. You have to watch this space. And the second thing is, as I said, as the head of the dental team, one has to advise and educate the whole dental team. So you have to know about it. So also there is an ethical and legal obligation to provide cover from infectious diseases, current and past. So a whole host of vaccines we have to take, you know, the hepatitis B vaccines, the flu vaccines, as the dentist, we have to take measles, mumps, and rubella. We have to be covered with all these. So there's about all these to the original list of vaccines. We need to add, I think, the COVID-19 vaccine for dentistry. So again, as a trusted healthcare provider, we have to advise patients what vaccine should be taken, and also to advise the family and extended family and the public about it. So this is my kind of last slide. So no one is safe until all are safe. I mean, this is what we are talking about is herd immunity. And I hope that everybody will start taking the vaccines. And there are a lot of anti-vaxxers, unfortunately, in different parts of the world, even in Hong Kong, where we have almost, we have all these SARS and SARS-CoV-2 and SARS-CoV-1. But I believe that with the increased efficacy and people realizing that if you are vaccinated, then you are not going to be hospitalized and hopefully die, then that will actually, they will see the light of day. And also, as I said, with the advent of a pill for these vaccines, then it will be really, really fantastic instead of an injection. A lot of people do not go there because of the fear of the injection. So I always say any vaccine is better than the no vaccine. Please don't wait for the good vaccine, because they are all very efficacious, as you saw in this presentation. So now we have seen how even a tiny RNA strand can change the world history. And so we have to be prepared for all these in the future. And once again, I would like to thank Dr. Donahue and for the Oral Pathology group for this, for the invitation. And I apologize for some of the technical hitches which may have occurred and all the phone calls. So thank you very much. And so this is my email. If you want to talk about vaccines or discuss any research projects, I'm happy to do those. Lakshman@hku.hk. Thank you very much.
Thank you, sir. That was a very interesting presentation. And yes, it was quite in-depth, quite nice. Thank you so much. Professor Krishnaraj, can you take the questions?
Yes, ma'am. Sir, firstly, hats off, sir, on a wonderful presentation once again. And as usual, you kept us hooked for an hour or so. And the way that you explained the immunology as a story, it was, it shows the teacher in you is always there. And it was wonderful hearing the lectures. Sir, from a clinical point of view, you also mentioned that any vaccine is better than no vaccine. So, how for the dental team, just your opinion, sir, how important would it be to keep checking the antibody levels, and is there any way to differentiate between sterilizing immunity and the one effective immunity?
So yeah, that's a very extremely very good question. Thank you for that question, Dr. Krishna. Yeah, so frankly, this sterilizing and effective immunity, quite a lot of people actually are unaware of it. That's why you get the variation. Now, how you check for this is a very technical way of doing it. But I believe, like for hepatitis B, just I want to go back to the analogy of hepatitis B. You can check, like if your antibody level is below 10 mega international units per milliliter, they say that you are not covered. And that is called the immunological correlate for that particular vaccine. In the case of the COVID, we don't have that the cutoff level so far as we know. So we don't know at what antibody level you will have total protection. Now, I'm not answering your question, I know that. But how do we differentiate between sterilizing and effective immunity? I don't know how you, frankly, people really have not come to that kind of depth of understanding of the antibody seroconversion to and to see how this is happening in the case of COVID-19 vaccines. Because my belief is that they have to be, like for example, you have to assess the antibody levels of people. You have to go back to past history and see how many of the vaccinated has given the immune infection to other people. So you have to go retrospective studies and prospective studies. So it's quite a large type of study, and with the with the benefit of time, we may have to find this. I believe, but I don't know whether Dr. Fraser, can you illuminate that, because I'm not like a specialist in this area, but this is my take of that.
Sorry,
you're on mute.
Apologies. First of all, thank you very much for an excellent vaccination talk. I think you covered a lot of ground. It was really a pleasure listening to you and watching the slides. Brilliant, really a very nice summary. And I think you answered, the questions that people usually have on, about the efficacy and effectiveness and the safety of vaccines and how they work and what they do. I mean, I have little to add. I mean, there are some issues, and I think we are navigating here in a unique situation where, on the one hand, there is a lot of development going on, and I think it's nothing short of a miracle that in less than a year after the discovery of a new infectious agent, vaccines were starting to be rolled out in populations. I mean, it's not just having developed them in record speed, but actually being able to manufacture them. And all the issues that we are seeing in terms of capacity of manufacturing and so on should actually not come as a surprise. I think that was entirely to be expected, that it takes longer to scale up production to vast numbers. I mean, this is, I think the world has probably never produced anything in such enormous numbers in such a short period of time. So I'm actually, and all those issues that arose, that company in I think in Baltimore in the United States that wasn't working up to standards, and where millions of vaccine doses had to be discarded because they had been contaminated or not well prepared. These things are regrettable, but I don't think that should diminish our trust or in the vaccines in any way. In fact, I think it's actually proof that the system works and that problems are recognized and are being dealt with, however painful it may be. However, I think in the public opinion, all those open questions and everything that we are, that is being changed as one moves along and learns more, that is often misinterpreted as a weakness. I get the feeling that people complain that, and there's side effects and this and that. I mean, we are hearing about side effects that affect 1 in 100,000 vaccinees. Yeah. We would never hear about that for other vaccines. I mean, it's just, there's a level of scrutiny and also of real-time information being provided and discussions going on behind the scenes. And of course, there are lots of discussions about what's the right way to do, to go ahead. For me, that is, actually, it just reinforces my ultimate trust in the systems. I think the world has done quite well, taken, in that respect. I think we have failed in big ways in many other regards during this pandemic. Very sad to run out of face masks, which is not a high-tech product. Very sad to, not really coordinate a response, fighting over supplies. There's lots of bad things, of course. But I think the vaccines are a good story. It's a very positive story. And finding rare side effects only after they have been rolled out in the population at large, which naturally you wouldn't find in trials that only enroll a few thousand participants. I mean, you can't find something which occurs in 1 in 100,000 if you only have 5,000 volunteers, which is already a large number. So I think for me that it's all ultimately extremely good news. And of course, like everything, there are issues, and of course we don't have the full picture yet. I mean, that is emerging as we go along. And I think the other, if and here in South Africa we are now really embarking on a major drive to increase vaccine uptake. For once, we do have sufficient capacity. We have enough vaccines currently. There were problems with the supply in the past. We have vaccination sites, and already they are not being used to their full potential, which is a huge pity, because we are just exiting the third pandemic wave, expecting the fourth one to start before the end of the year. And already the third wave was, at least the negative effects on the elderly and risk groups should have been largely preventable if people had taken up the vaccine timelessly. So we are embarking on a drive, and arguments about the need for booster doses and which groups to include, talking about now adolescents 12 to 17 years, because anyone above age 18 is now can now have the vaccine in South Africa, but this is adolescents are now the next group. And one can talk about it and one makes a decision, and it may be right or may be wrong. In hindsight, of course, it'll be a bit easier to say, and of course it mixes with all other measures being taken, and it'll change. And I think it's a strength of that one adapts to emerging evidence and changes it. From a laboratory perspective, we have over the past year or so tried out different tests to look for immunity and past infection. So we can, I think, to a large degree, distinguish between the two quite reliably by looking for specific antibodies against the spike protein, which is the component of the currently available vaccines. That we don't use Sinovac here yet, which is inactivated, which would also or should elicit antibodies against the viral N protein. And so if we find N protein antibodies, that would indicate past infection. If we find anti-spike antibodies only, that would indicate just vaccination. And the highest anti-spike titers we found in patients who had the real infection and then subsequently had a dose of the vaccine. And that probably means very good immunity. But of course, the ultimate proof, and there are lots of studies again that make it quite difficult to wade through. The ultimate proof, of course, is looking at the how they will do and how far they become infected again. And that only time will tell. And it is not easy to keep have good records on patients as the vaccine program is rolled out. And of course, we also know that only a minority of people who had COVID were diagnosed as such. So there are far more people who had the infection, and unless we test for them with using a suitable test, we will never know, and then they will become part of the vaccinees group. And but in fact, this is a group composed of people who are survivors of COVID with natural immunity, then boosted by vaccination, and others who were just vaccinated. And of course, we also see a lot of breakthrough infections, particularly in healthcare workers. That was the first group to be vaccinated here from February onwards, and where, of course, serious disease, severe disease, and death are much less prevalent during the third wave, which is just ending now, than during the previous two epidemic waves. So, I mean, the vaccine works. It protects against severe disease and death, but it doesn't, at least in our hands, protect against infection as well as one might have hoped, probably unrealistically so. But there was sort of the idea we would have fewer healthcare workers becoming infected, and then, with everything that it means, even if they're not severely ill, having to go into isolation and then quarantine for their contacts and so on. So that is very disruptive to the health system. And of course, it would be nice if we could avoid this. And at this stage, we cannot. In future, however, I do foresee a period when we know that vaccination coverage is so good across the population that we will no longer have to really worry about somebody having mild infection and potentially becoming infectious for a few days, because whoever they expose during that time, and of course there will remain certain rules like masking and so on, but whoever they may expose, in turn has a very low risk of severe illness and death. And that's, of course, for me, that's the ultimate goal. That's what we need to achieve so that we can return to normal operations, and in the process would save a lot of effort, money, disruption, and so on. So I think that is where we are heading. At this stage, however, I wouldn't feel confident testing somebody and then determining whether they are immune or not. We are now starting to test the patients that we've tested with a number of different assays that look for binding antibodies that we think correlate with neutralizing antibodies. We are going to test the same samples also with a neutralizing antibody assay. But again, that is only part of the equation. Of course, there is cellular immunity, there is immune memory, and there's many facets to it. So I'm not sure how soon we will have a surrogate marker that is easy to determine, possibly even by means of a rapid test, a rapid antibody test. I'm not sure, whether that will help. Perhaps if it's not too sensitive, so that it only picks up people with antibodies above a certain level, if of the right specificity. So I think there is a lot of work still ahead until we get to a stage where we can use antibody titers to determine whether somebody is currently immune, and I think that's a practical consideration, particularly for the health system, whether somebody should go for a booster dose. And again, I think that we are learning, and I sometimes feel that being in a country like South Africa is not such a bad thing, in that others are going ahead. So we can also learn from their experiences by vaccinating their youth. So it's let the UK and or not the UK and the United States and Germany go ahead, and let's learn from their experiences in vaccinating a few 100,000 adolescents, and that will very beautifully provide real life data on how safe and how effective the vaccines are in this group. And likewise, the heterologous prime boost approach of using the one vaccine for the first dose and then another one for the second dose, which is founded in data from previous, for example, HIV vaccine trials. So, there is, of course, decades of work on vaccines for various types of infections that fed and feeds into the whole COVID vaccine development. And I think it's marvelous. That we still don't have an HIV vaccine, but the work on an HIV vaccine has really provided a lot of the foundations for what we are seeing now, and I think that's marvelous. It shows the value of science as such. You invest, you work, you study, and even though you may fail in what you set out to do, which is the HIV vaccine, ultimately this is now really providing enormous benefits. There's still no HIV vaccine, but we have a COVID vaccine within a few less than a year. So that's quite amazing. And that data on the heterologous prime boost that was boosted, if I may forgive the pun, when Germany advised people younger than 60 years of age not to have the AstraZeneca vaccine because of the clotting issue. So they then said, well, if you had your first dose and now you're coming back for your second one, that should be done using one of the mRNA vaccines that they have approved there. And it worked, it worked very well. I mean, the antibody titers are very high. But it was sort of a, it was a workaround in a tricky situation, even though, I mean, one can argue whether that was warranted in the first place, not to give a second dose of AstraZeneca. And I think there, is a good argument to be had. I think this was out of an abundance of caution. And they changed recommendations over months and again confused people no end. I mean, that's the downside, you want to act in the best, based on the best current knowledge, but in the process you lose people because not everybody can follow the intricacies of the scientific argument. But what it ended up with is a sort of a natural experiment whereby people received a pseudo a viral vaccine as the first dose, and then an mRNA vaccine as the second dose, and it worked very well. So this is so it's all those things, and it's very difficult to foresee. It's not a formal trial. It's a real life type of study that set out actually to overcome another issue rather than proving that this is a viable approach, but in the process achieved this. I think it's a fascinating subject. I think one needs to keep in mind that it may probably be overwhelming. And I think there are people out there that pick those little issues that are not quite clear and really out, look at these extremely rare side effects, but not realizing that the risk of something which occurs in 1.5 million of vaccinees is totally irrelevant. I mean, that is not anything that a person can base their personal decision on, because the risk, I mean, here I joke, and I'm not sure about road traffic in India, but here I joke that the drive to the vaccination site and back is actually riskier than getting the vaccine. I mean, by far, because the chance that somebody will run you over is far worse than the very remote chance of 1.5 million of severe side effects. So it's a complicated argument, and I think it was a brilliant talk that really highlighted these pertinent issues. Thank you.
Yeah, thank you. I just want to say two different points. I mean, I just want to pick up on the point made by Professor Praiser. Yeah, it's if you take 1 million people or 500,000 people in a given day, how many of them are going to die or have some lethal disease? I mean, it's likely somebody's naturally die. So you can't equate that with vaccine because of the vaccines. So they are coincidental, not they are causal. So that's number one. So these are coincidences. And a lot of people, anti-vaxxers, I tell them, look, you can't go to school without taking any of these vaccines these days. So everybody has to take. I don't know, there may be few exceptions for religious grounds and so on. So these are the two major arguments against this. But there'll be always anti-vaxxers. They pick up on, as Dr. Prof. Praiser has very clearly explained, on these small points, and they make a big issue out of it. Yeah, thank you.
So just if I may, a couple of more that is the Dr. Osmani Guevara. He asks whether the hypothesis that major histocompatibility complex reacts faster and is more efficient in asymptomatic patients. Is that true? And what's your opinion on that?
Major MHC reacts faster
and is apparently more efficient in asymptomatic patients. Do you care to comment anything on that, or anything?
MHC is, I frankly, I mean, I can remember that I showed you the why different people get different responses to the vaccine with different circles. Each person's MHC is different. So, I mean, in slightly variations, because each individual is different. So, I have not seen any specific papers on this.
Data
I
on that.
don't know whether this question person has seen it.
Yeah, very difficult to find it. Yeah.
Yeah. So your MHC is different from mine because there are slight variation. MHC is major histocompatibility complex, means that it's the surface antigens of your cells. So for example, that's why you can't do type A blood to type B, and you can mix and match and so on. So it's all, yeah, it's possible. I don't know in the papers of, but I still I can't. So certainly MHC plays a role, but I don't know what or when it plays a role in vaccination.
Dr. Sandhya Tamgadge also mentions that she's curious to know the details of the background histopathology picture of Professor Preiser.
Me? You want to ask?
Dr. Professor Preiser. He says she wanted to know about the background picture.
Oh, the background.
Professor Preiser had a background picture of the virus.
Yeah, that is the virus in cell culture. I got that as a Zoom background from the Robert Koch Institute, which is the German National Health Institute. Yeah. Thank you for the compliment.
Yeah, it's very nice, very appropriate.
Amazing.
I need to get a similar background. I have one.
All right.
There's one more question.
If there are no other questions, yes.
There's a question from Dr. Osmani. A third dose, is it necessary? And in Ecuador, where he is from, they're using Sinovac.
Sorry, I didn't
any news on that?
So in Ecuador, they are using Sinovac. So what is the question?
Would the third dose be necessary?
Yeah, I mean, this is the very hot argument, right? Sinovac, the efficacy is 50 to 60%. When initially when they came along, a lot of people said, compared with the mRNA, which is 90 to 95%, this is very low. Therefore, you may have to take additional booster doses. So the booster doses are very much, the whole argument about booster doses are very much up in the air. So it is likely the way this Delta variant is becoming a super spreader and highly infectious, that all of us might have to take not only those with the Sinovac, but even those with Pfizer may have to take the additional booster dose. Like for Hep B, we take 3 doses. Even Johnson & Johnson now saying that they came up with only a single dose vaccine. It said they are effective about, I think it was about 60 to 70%. But now they say they prefer to give 2 doses for proper, immune response and, antibody response. So it's highly likely that everybody will have to go to 3 doses. That's my personal view, but I don't think there is any WHO or whatever.
I think Professor Preiser has something to say about this.
Yeah.
Yes, thank you very much. Absolutely agree. I think ultimately we will probably need more doses. How often, in what combination, talking of, again, heterologous prime boost strategies, and how well then, and how long-lived protection will be. I think these are all data in the making. So, and the 2 big lines are WHO says no. You've got your basic immunization, you stick with that whilst we vaccinate the rest of the world. Yeah. And of course, the countries that have surplus vaccine are saying, no, but we have risk groups. I think at this stage, the evidence is probably good for people who are immunocompromised to have a booster dose now. Yeah, very good. There is also a push for the healthcare workers that had the J&J vaccine here in South Africa and are experiencing a lot of breakthrough infections. And as you mentioned, the J&J is it's a selling point that it's 1 dose only, but I think everybody has to agree that 2 doses is better than 1, and perhaps that is not actually the booster. This is just the second dose of a 2-dose regimen. So I think all this is very much in flux, and there is lots of studies and observational studies, but also trials going on to look at these. So I think it will become a lot clearer. And of course, the other spanner in the wheels, if one wants, is the Delta variant, which sort of played havoc with the planned rollout of the vaccines, and we thought we've got everything under control, but now it has an increased likelihood of causing breakthrough infections because it partially evades the immune response. So, and it's an ongoing story, and I don't think we've seen the last of the variants yet. There are, of course, nasty surprises that may still arise, and I think one needs to really watch this very carefully. But on the other hand, I think the comforting news is that if somebody with a near normal immune response, so not severely immunocompromised, so the average person who had a primary course of the vaccine is well protected against severe disease and death. And I think that's the for the time being, I think that is the message that needs to go out both to colleagues who are by the nature of their profession, of course, highly exposed, but also to the public. I think that is the main argument for being protected. And of course, there is the altruistic element, which some people now say, well, if I can still be infected and infectious after being vaccinated, so why do you care? Why do you worry about it? It's my choice. Well, yes, it is your choice until you end up in intensive care, taking the bed and the ventilator, that somebody who doesn't have COVID, but may have a myocardial infarction or something else, or needs urgent elective surgery for cancer. If somebody like that cannot be treated because the bed is taken up, and I think that's something that is often omitted from the discussions. We see that a lot here at our Tygerberg Hospital, which is a top-level hospital for the province. So it deals with the severe cases in the public sector, the demanding medical conditions, and medical services had during the waves had to be scaled down immensely. And of course, people come to harm. If you're diagnosed with cancer and you cannot be operated on now, that is a very real. It's not COVID that is killing you now, but indirectly it is, because the hospital capacity is down. And I think that's also something to keep in mind. I mean, to stay out of intensive care and high level care, also frees up the health system to deal with other cases, and we need to do that. I mean,
collateral damage.
Yeah, absolutely. And we are very worried to see that about 30% fewer tuberculosis cases were diagnosed during the pandemic than one would have expected. So, of course, tuberculosis didn't go away. Those cases are still out there, but they have not been recognized. They are not getting treated. They are transmitting to others. So there are lots of very real and pertinent issues. So I think we need to move out of this COVID, to some degree, to as much as we can, to be able to focus on everything else again.
Yeah,
I have one question that is open to all of you. There is this, we have this thing because COVID basically, even itself, and then by default it's vaccines, has a lot of immune reactions. Now, what is the status? I do know that in many countries, they have advised, like in the USA, they have advised even people who have things like rheumatic heart disease or various rheumatic involvement or autoimmune diseases to take the vaccine, because the risk of not taking it is more than taking it and whatever else may happen. But has anything been worked? Because people with autoimmune responses, especially like RHD, are essentially people whose immune reaction to begin with was faulty, which is the problem, because you had a cross reaction to one bacteria that acted with the heart tissue. So anything that you have come across in your work in terms of this, what is current status?
Yeah, so that's a very, very good point. I mean, people get after the vaccine end up with myocarditis. Actually, it happened to a friend of mine. His son, 12 years old, the child developed myocarditis. I mean, he's a very healthy child. So this we talk about the cross-reacting antigens. Just like, can you remember the strep mutant story? Earlier, they could not produce a vaccine for caries because they shared the same antigens, the antigen A or B or whatever it is, the outer covering of the strep mutants had same antigenic composition as the heart tissue, cardiac tissue. So that was went out of the way because of that. So yeah, so your question is very, very good. And I think that my advice is, not my advice, what I have heard is that people with autoimmune diseases and your immune response is very poorly, then of course they are not asked, because of course, by virtue of their condition, there will be no antibody response. So perhaps they can be given immunoglobulins. I really don't know. I mean, but immunoglobulin treatment, it just lasts for just 1 week or some couple of weeks, and then the proteins get destroyed. So as far as I know, I think people with these sort of immunological abnormalities, as you mentioned, Dr. Donahue, I think they have been asked. I know somebody in UK. They said it's better not to get vaccinated because it may create another reaction. I really don't know what the situation in South Africa or other parts of the world are. I know in UK they do not persuade them to get vaccinated if they have any immunological abnormalities or in this immune system abnormalities. Yeah.
Yes, Professor Preiser, anything you can add?
Thank you. Yeah, I don't have first-hand experience other than inquiries from people who have conditions. I mean, and usually the problem is that the same condition that makes people worried about the effect of the vaccine also puts them at high risk of severe COVID. So I think in balance, while there is a very high infection pressure like we are experiencing, clearly the vaccination is the route to go. One would not want to risk infection. Ultimately, I think there is firstly the need to, and there are very few genuine contraindications to the either vaccine. I mean, in principle, we only have Pfizer, BioNTech, and J&J in South Africa, so I don't know about the others, but from what I see, the true contraindications are very limited to a very defined, specified range of conditions. In which case, then of course the alternative vaccine should be used, and that is an issue if that is not available in the same context. So I think that's also something we need to look at in the future. But it's a very small number of people who are affected. That some of them will not mount a very good immune response is another issue, and I wonder whether improved vaccines may help, or whether, in fact, going forward, or maybe they need to rely on everybody else being immune so that the infection pressure is lessened. So that's another altruistic aspect of becoming vaccinated, that by doing so we are reducing the risk for those who, for whatever reason, can't, or have been vaccinated but won't mount a good immune response. And I think that is quite a significant proportion of the population. In South Africa, there is a large number of HIV-infected people, and even though clinically they are not doing as poorly as we had feared initially, so COVID is on average, tends to be more severe, and there's a higher proportion of fatal cases in the HIV-infected, but it doesn't stick out. It doesn't compare with diabetes, for example, or morbid obesity, which is far higher in terms of being a risk factor. But of course, still there is an elevated risk, and those whose HIV infection is not well controlled, will not be optimally protected from the vaccines. So again, it's something that one needs to look at and improve on going forward. But I think at this stage, one can really take consolation in knowing that the vaccination, real-life vaccination scenario is being closely monitored. And what I found absolutely amazing is that after the brief interruption of the J&J vaccination campaign, after the clotting issue became apparent in April, and many countries paused it for about a week or 2 weeks or so, and some abandoned it completely, but most others actually returned. Then within a couple of weeks, the risk groups and risk factors had been delineated, and diagnostic and therapeutic regimens had been developed, which I find absolutely marvelous, because that means that those few cases that would occur of this potentially very risky, dangerous adverse effect, they can be managed much better. So that further lowers the risk of patients to come to serious harm or even die from it. And I think that is a wonderful thing, isn't it? It's great. So the surveillance system works. We are learning about these cases, and I think for most of us who don't have a particular interest in these matters, nothing that has come up so far should change people's mind. I don't think that anything about the vaccines that we've learned distracts from the message that please get vaccinated if you can. Don't worry about which vaccine, but do it the sooner the better, because it takes time to work, and that is our way out. And then let's see what comes up in terms of booster doses with the same or different vaccine, and maybe also reformulated vaccines. And I know that companies are working on that to embrace also some of the variants. So I'm sure there is lots of innovation coming our way. But at this stage, clearly what we have is already very good, and that's the way to go.
I think it's just Dr. Krishnaraj, I think you need to bring in the dental view into this now on the clinical dentistry. So what is your experience? Are our colleagues all getting vaccinated? Do we have people who are not getting vaccinated? And then what is the response of patients? Are patients asking their dentist, are you vaccinated?
Yeah, so yes, so we are in the second year. We always thought COVID is going to go away, it's going to go away, but it never happens. It's been 2 years. We're living with it. It's affected business quite badly, and it affected the team morale to a large extent. And usually when we have normally in the practice, we have patients who undergo both emergency and elective procedures. So during the time of the pandemic, people were only focused on getting their emergency treatments done, which is extractions and maybe a few root canals and stuff. But a lot of elective procedures were being postponed, and businesses were affected quite badly by this. Now, there is after COVID fatigue, both from the medical, our professional side as well as the patient side. Patients have started coming. And every COVID, every pandemic, we know that it's bad, but it has a silver lining. And I believe that the take-home message is that in India, the level of infection control that has been practiced has gone up tremendously with the use of PPE kits, with the use of fumigation devices, fogging machines, usage of hand sanitizers, getting B-class autoclaves into the system. It's an excellent opportunity, and because from a business point of view, COVID has leveled the playing field for everybody, whether you're a senior practitioner or you're a newcomer to dentistry. Everybody has to start from zero. So if you have to do that, this has been the perfect time. And we displayed the vaccination certificates of all our doctors on the panel board for patients to have a look, and that way it's good. We also try and give a certain incentivize patients by offering them some freebies and some discounts to make sure that they are vaccinated, so that they get some benefit. It acts like an incentive for them to vaccinate themselves. We also get routine antibody levels checked of the staff. From that point of view, it doesn't cost much, thankfully, due to the intervention of the government and the regulatory agencies, that the cost is kept under control. So it becomes affordable to routinely test all the staff a new thing that I learned today is about the different types of antibodies, the sterilizing antibody, effective immunity, and the sterilizing immunity. So I guess that is something that we also have to look forward to. As far as the team morale is concerned, initially there was a lot of fear, especially in practicing dentistry in this time of pandemic. But now, I guess things are just more or less back to normal, and with all the regular precautions, standard precautions that we take, assuming that every patient is COVID positive, going ahead forward is the right way to go. I do sincerely hope that once everybody gets vaccinated, all the herd immunity kicks in and everything, we don't go back to the previous era where our infection control standards we drop down or drop our guard against that, because like sir mentioned at the beginning of his talk, whether it is hepatitis B, tuberculosis, COVID, in future there could be many more. So this is a good lesson for all of us. And another thing that sir also mentioned is that the ACE inhibitors being the highest level in the oral cavity, the chances of oral infections or the oral cavity acting as a reservoir or acting as a foci of infection for spread, both for the community perspective as well as from the systemic point of view, remains to be keenly observed. So with this in mind, I urge all dental practitioners, and I always believed that dentists have to start working, because you can't be always live in fear. And get yourself vaccinated, follow the right protocols, get your work, because I know a lot of dentists, because of the fear, have today, after a year and a half, lost confidence in practicing dentistry.
Krishnaraj,
So the dentists are there.
You're breaking up.
Okay.
Okay. Oh, yeah. Thank you for that. Yes, that is true. That's what we need to do. I think we have just a few minutes left, and we'll have one closing remark, I think, from Professor Preiser, and then we shall wrap up.
Sure.
Thank you very much. I'm very glad to hear the appeal to for dentists to become vaccinated, and of course I don't have any statistically valid evidence from South Africa, but of 3 dentists that myself and 2 colleagues whose patients they are, we've heard all 3 are relying on rubbing themselves with ivermectin, the cattle paste, but are refusing to become vaccinated. 1 out of the 3 already, to our knowledge, I mean, we don't know about the other 2, has been infected with COVID and had to delay the planned treatment. So I'm very glad to hear that, in India, the dental profession seems to be more, adherent to mainstream science. I can only join in the appeal. I think there is no valid argument in the vast majority of people. I mean, aside from those very rare cases where there are true, genuine contraindications, but there's always the other vaccine. I think this is what will keep ourselves alive and healthy. Not to forget also the impact of long COVID. I personally know of several people who have had COVID and who are really struggling to recover after many months. So that is not nice. It will really impact one's ability to work. So long COVID is an issue, and of course the acute case is in many cases anything but a good experience, even if one doesn't come to permanent harm. And of course, to protect patients. And I think that, my dentist is now left for the United States. I think he'll soon have to get vaccinated because they are not taking much nonsense there from what I hear. But, he's a great dentist and I'm vaccinated, so I feel confident. But I think people have a right to know that they are as safe as can be. And I think it's part of that is, the clients, the patients. And I think part of that is that you do very good infection control in your practice. I mean, you would not treat somebody using the gloves that you've used on a different patient previously, or giving an injection with the same needle that you've used on a previous patient. These things are, an integral part of our medical practice to keep people healthy. And I think being vaccinated as the healthcare provider is really along the same lines. You want to avoid harm. And of course, it's not just altruistic, it's also in the interest of the practice to stay healthy and productive. So, I can only join that. And I would like to, I really learned a lot this morning. Thank you very much for this excellent presentation and the subsequent discussion. I really enjoyed that. Thank you.
Can I just say, Dr. Manda, just one
Yes,
couple
please.
of sentences?
Yes,
Yeah,
please.
so I just actually heard something very interesting. Those who are saying they don't want to get vaccinated, they say they have the right not to get vaccinated. And then there's another guy, somebody who told me, yeah, we also have a right to live. So the other guy said to me, I have a right to live as well, So you have to respect my right to live and compare it with your right to get vaccinated.
Yeah.
So thank you very much.
Yes, that's true. That's been a very interesting thing, COVID, because it brought so many very different things out. One is, again, these things where before we never had this problem because most vaccinations were to save the person getting vaccinated. Today, we are telling people get vaccinated because you need not just to save yourself, but everybody else. So that's a very different thing. Also, I think it's the first time where medical development and research is happening absolutely in the open, where they see us and they see the medical profession changing. This has always happened with everything, but it has happened behind closed doors, and the end result has been presented to people where everybody was sure of what it was. So this constant changing has never been a part of what the people or the public saw, which is one of the different things. They're seeing a very different face of, like how we say now the WHO has been changing its tunes for so many times, but that's sort of made everybody a little unsure, but it is true. And like Professor Preiser said, and Sir Lakshman Samanaik sir also said, things are happening in the open because they are just developing as we go. We are literally doing this as we go. There is not really done before and practiced and tested 10,000 times. It's just as it goes. And it's been a very interesting time. And thank you all so much for this very interesting interaction, lovely presentation, lovely discussion. And the audience is thoroughly enjoyed it.
Okay.
Yes. Thank you, sir. Thank you so much.
Yeah, thank you so much for the invitation. I really enjoyed listening to everybody, and good to get to know Dr. Preiser as well. And Dr. Krishnaraj, of course, I know him very well. And thank you, Dr. Mandana, for everything. Take care. Be safe.
You, sir. Thank you. You too. Take care, sir.
Thank you very much. That was
Thank
really
you.
enjoyable. Thank
One
you for
second,
organizing,
Professor Preiser,
for
your
having me.
certificate is here.
Okay.
Oh, fantastic. Thank you.
Yeah, thank you so much.
Thank you very much
for
indeed.
everything.
Okay.
Thank you. Thank
And
you.
yes, Professor Krishnaraj, and here it is your certificate. Thank you so much.
Thank you, ma'am. Thank you so much.
Thank you. Thank you. And now I have just a few announcements to make. Yes, of course, thanks to all the viewers who make this possible. And we have had our regulars from around the world. Thank you so much. And thank you for interacting. And yes, news about coming Tuesday is another one that actually I think Samar Naik sir would have liked. It's about continuing in the same line, sort of in the same line, or one that he likes, is about oral microbiome and oral cancer. Dr. Priya Deo is speaking, and Dr. Supriya is going to be the moderator, and Dr. Tilak Ratne, of course, is going to be the expert. And this is something he has already spoken about quite a few times, and he is doing some work on it. So this should be very, very interesting. Another little bit of interesting information for you is that we have what is going to be for the first time an oration, a dental oration and storytelling international contest. So Dosti 2021, or as it is we know in Hindi, is friendship, because it's finally all about connections. And inevitably, everything we do is about connections. Our life is not just a science, and it is everything else that we see. The contest will open after the September 20th. This is for you to just get your stories organized. And yes, with this little video about it, we shall say bye to everybody. Thank you and see you all again. Thank you. So see you next week, and the link for taking the test, if you would like to, is in the description of the video. Take the test as many times as you want. If you want to get the certificate, follow the link. See you next week. Bye.